For our second day exploring Investigation 5.2, we're going to focus on word problems. So again, you're going to follow a similar format to yesterday where you're going to work through some guided notes, and then tomorrow when you come to class, we'll work through more problems together. So the first word problem talks about how on a rural highway, a police officer sees a motorist run a red light at 45 miles per hour. The police officer finished putting gas in his car before he began his pursuit. At the instant the police officer passes through the intersection at 50 miles per hour, the motorist is 20 miles down the road. So when and where will the officer catch up to the motorist? You should recognize this as a system of equations problem because, again, we're trying to figure out an intersection point. The when and the where will they meet up. So we're going to first start by finding some missing values in a table. A table is one way to approach a system of equations problem. So we have time and then distance for each person. And so again, from the problem, we can see that the motorist is going 45 miles per hour. So as each hour increases, the distance is going to increase by 45 miles. So this is going to be 65 miles and then 110 miles. And then for the police officer, we can see from the problem that that person's rate is 50 miles an hour. So we're going to be going up by 50s here as each hour increases by 1. Now we're going to define our variables. So x in this case is going to represent the time in hours. Y is going to represent our distance in miles. So now we're going to go ahead and write a system of equations in two variables. We just defined those two variables right here to model the situation. So the motorist, we're going to set up an equation, y, the distance of the motorist, equals, the motorist is starting at 20, and they're adding 45 miles per hour, so 45 times x. The police officer, y, their distance equals, they don't have a starting value because they're going to just be starting from when they fill up the gas tank, 50x, so 50 miles per hour. So now we're going to use the substitution method to solve this problem. And you'll notice that both of our equations are already set up for y equals. So we can actually just set these two equations to equal each other. 20 plus 45x equals 50x. And so we can set this up to solve for the variable of x. I'm going to subtract 45x, subtract 45x. I now have 20 equals 5x. Divide both sides by 5, and I have x equals 4. So that's a start to solving the system, but again, I have to actually find the other coordinate that goes with it. So now I'm going to go ahead and plug in the 4 into both equations and make sure I get the same y value. So 20 plus 45 times 4 would equal 20 plus 180, which would give me 200. And then the other equation, I have 50 times x, so 50 times 4, which would also give me 200. So 200 is going to be my y value. And again, I'm going to ultimately express my answer as a coordinate pair. So in this case, my solution is going to be 4, 200. Now, because I'm dealing with word problems, I also want to be able to actually put that in a context of a problem and explain its real world meaning. So what I'm going to say is that they will meet up, right? So the police officer will catch up after 4 hours at 200 miles. So that would be, if I graphed those two lines, that would be their intersection point. That would be called the solution to that system of equations. For the second problem, we have a pharmacist with a 5% saline solution and a 20% saline solution, and they want to make 90 milliliters of a 10% saline solution. So you're noticing that we're adding two different solutions together, and then we're ending up with a different solution at the end, and we want specifically 90 milliliters of it. So we don't know how much of each one to mix. So we're going to let our x equal the amount of 5% solution, and we're going to let our y equal the amount of 20% solution. I'm just using SOLN to abbreviate solution. So writing an equation for the total volume, we're going to let our X plus our Y equal 90 milliliters, since that's the total volume we want to make. And then our equation for salt, because we also have to make a specific concentration, we're going to set up 5/100 X, again that represents 5%, plus 2/10 Y, that represents 20%, equals 1/10 times 90. And that's our 10% solution, and we want 90 milliliters of it. So now that we have our two equations, 1 and 2, we're going to go ahead and solve this whole system. And I should also say we can simplify just a little bit more here. So we can say 5/100 X plus 2/10 Y equals, and we can combine these terms together, and a tenth of 90 would be 9. So we can actually use this equation here. So you'll notice that neither of these equations is solved for one variable. So one of the first things I'm going to do is I'm going to rewrite X plus Y equals 90 to solve for one variable. And for today, I'm just going to go ahead and pick to solve for X. So I'm going to subtract Y from each side. So I get X equals 90 minus Y. And so now I can substitute that into my other equation. So I have 5/100 X. So again, I'm going to substitute this in for X. So times 90 minus Y plus 2/10 Y equals 9. And so now I'm going to need to distribute the 5/100 to each of these terms. So 5/100 times 90 is going to give me 4.5 minus 5/100 Y plus 2/10 Y equals 9. And again, now I have more terms that I can combine. So I'm going to go ahead and combine these two right here, the 5/100 or negative 5/100 plus 2/10 Y. That's going to give me 15/100 Y. And then I'm going to subtract 4.5 from each side so I can combine those like terms. So now I'm left with 15/100 Y equals 4.5. And when I divide both sides by 15/100, I have that Y equals 30. So that's my first step, is to solve for one variable, and then again I'm going to plug this into my equations and check to make sure that I get the same X variable in each. Then I'll know I found the correct solution. And so I'm going to go ahead and go back to this equation first, the X plus Y equals 90. So X plus my Y is 30 equals 90. And if that's true, I subtract 30 from each side, I'm going to get that X equals 60. So I'm checking my other equation now to make sure I also get 60. This one's a little bit longer, right? So 5/100 X plus 2/10 Y, so 2/10 times 30 equals 9. And so as I work through this, I have 5/100 X plus 2/10 times 30. That's going to give me 6 equals 9. And so now I can subtract 6 from each side. So I get 5/100 X equals 3. And I know I'm a little tight on space here. I'm going to divide by 5/100 on each side. And I ultimately get that X equals 60 also. So that tells me that I found the correct solution to these equations, solution to the systems of equations. And so I'm going to represent that as a point. So it's point 60, since the X is 60, and then Y equals 30, so the point is 60, 30. And so now the real world meaning of that solution, I'm going to say that I need 60 milliliters, right? I'm going back to my X, is my 5% solution, and I need 30 milliliters of 20% solution to make 90 milliliters of 10% solution. And you'll notice, right, 60 plus 30 does make 90, makes that total, just like I was checking before. The next problem is going to deal with making a mixture of pecans and pistachios. So in this case, pecans cost $4.50 a pound, pistachios are $5.50 a pound, and so we want to know how much of each type we're going to need to make 14 pounds of a mixture that's going to cost $71. So we're going to let our X equal pecans and our Y equal pistachios. You could do this the other way around, but that's just what we're doing for today. And so now we're going to write a system of equations. And so one of the equations is going to be about pounds, and one is going to be about cost. So for pounds, my X plus Y is going to equal 14, because that's how many pounds I want of the mixture. My cost is a little more complicated. I have to think about those different rates. So 450 times X plus 550 times Y is going to give me my $71 as my total cost. So next we're going to solve this algebraically. You'll notice we're going to have to solve for one of the variables. So I have X plus Y equals 71. I need to choose a variable to solve for. I'm just going to choose X. So I'm going to subtract Y from each one, and I get X equals, oh, I used the wrong number here, didn't I? X plus Y should equal 14. So X is going to be 14 minus Y. All right, so now we can go ahead and substitute that into the other equation for X. So 4.5 times X, so 14 minus Y, plus 5.5 times Y equals 71. So you can see we need to distribute the 4.5 to each term, being careful of that subtraction sign too. So 4.5 times 14 is going to give us 63 minus, because there's a minus sign here, 4.5 times Y plus 5.5 times Y equals 71. So now I'm going to go ahead and combine some like terms. So I'm going to subtract 63 from each side. And at the same time, I'm going to combine these right here. So negative 4.5y plus 5.5y is just going to give me y. Right, that would give me 1y. So I'm going to say y equals 71 minus 63 is going to give me 8. So I think that y equals 8. But I'm going to check with my equations. So going back, x plus y, I think is 8, equals 14. Subtract 8 from each side. I have x equals 6. Again, I'm going to check my other equation as well, just to make sure that it works. So 4.5 times x plus 5.5 times y, which is 8, equals 71. So I'm going to go ahead and combine what I can. So 4.5x plus 5.5 times 8. That'll give me 44 equals 71. And now I can keep balancing my equation to figure it out. So 4.5x equals 71 minus 44 will give me 27. And now I'm going to do 4.5. I'm going to divide by 4.5 on each side. So 27 divided by 4.5 is going to give me 6. And so you'll notice I was able to get 6 on each of these. So that tells me I found the correct solution to the system of equations. However, again, I'm going to represent this ultimately as a coordinate pair or an ordered pair. And so I'm going to call this point 6, 8. And now I need to explain its real world meaning. So in this case, I'm going to say that I need 6 pounds of pistachios, or I'm sorry, of pecans, and 8 pounds of pistachios to get 14 pounds of a mix for $71. Our final problem has to do with an amusement park, and they want to know how many adults and children went to the park on a specific day. So the park charges $25 for an adult ticket, $15 for a child's ticket, and there was a particular day when they sold 304 tickets and they collected $5,320. So that's a specific combination of adult tickets and children's tickets to make that exact number. So we're going to actually use variables of A and C this time. So we're going to let A represent our number of adult tickets, and we're going to let C equal our number of child tickets. This is just like using x and y. Again, it's just different variables. So now we're going to write a system of equations with our two variables. And so we're going to set up adult tickets plus child tickets equals 304. And our other equation is going to be about the cost of the tickets. So 25A, because it's $25 per adult ticket, plus 15C equals 5,320. So now we're going to solve this algebraically. So we need to choose a variable to solve for. So I'm going to take that first equation, A plus C equals 304, and I'm going to go ahead and just solve for A. That's just what I'm happening to pick this time. So I'm going to subtract C from each side. I have A equals 304 minus C. So now I can plug that into my other equation. So 25 times A, 304 minus C, plus 15C equals 5,320. I'm going to go ahead and distribute my 25. So 25 times 304 is going to give me 7,600. 25 times C is going to give me 25C. Again, note the subtraction sign here that has to continue. Plus 15C equals 5,320. Next step, I need to combine some like terms. So I've got 7,600 over here. I'm going to subtract that from each side. And then I'm also going to combine my C terms here. So I have kind of like a negative 25C plus 15C, so that's like negative 10C. On the other side, when I subtract, I'm going to get negative 2,280. So negative 10C equals negative 2,280. I'm going to divide both sides by negative 10. And so I have C equals 228. So that is what I think the number of children's tickets is, or child tickets. And so now I'm going to go ahead and plug in that value so I can figure out the number of adult tickets. So A plus C equals 304. So A plus 228 equals 304. I'm going to subtract 228 from each side. So I get A equals 76. Again, I've got to go ahead and go back to my other equation as well, just to double check. I know a space is tight. So I'm going to go ahead and plug in 25A plus 15 times C, which I think is 228, equals 5,320. And so I have 25A plus 15 times 228 would give me 3,420 equals 5,320. Going to subtract from this side here, from both sides, and I get 25A equals, right, 5,320 minus 3,420 is going to get me to 1,900. And now I'm going to divide each side by 25. So A is going to give me, hopefully the same answer as before, 76. So you'll notice again my cost, C equals 228, A equals 76. I need to be careful when I write this as an ordered pair as a solution. So note my A is kind of like my X and my C is kind of like my Y. So I need to make sure I'm writing A comma C for my equation, or for my coordinate pair, I mean. And so in this case, A comma C is going to be 76 comma 228. So the real world meaning of that means I need 76 adult tickets and 228 child tickets to get a total of 304 tickets that cost $5,320. So again, that represents a specific solution to this system of equations, right? If I was to graph both of these lines, that's where they would intersect, and that was where I would call that the solution. So that's it for our notes. Hopefully tomorrow you're ready to do some more of these on your own.